Hello, everybody. I hope you all had a wonderful break. I'm sorry I'm not there. We're going to try our best to go ahead and do some notes until I get back. I promise you I will go over whatever questions you have when I return. But we're going to try our best this way. It should be a pretty low-key week for you guys until I return. So, what we're going to look at today, we're going to pick up where we left off with properties of logarithms. So we were talking about logarithms right before break. You guys had a little practice with those yesterday. So now we're going to look at some properties of logarithms. We're going to look at two different things. Today we're going to look at how you can expand or condense logarithmic statements. And then tomorrow we're going to look at how we can rewrite logarithms using different bases. And I'll explain that more a little bit tomorrow. But for now, let's look at some of our properties of logarithms. So we've got three important properties with logs that are going to allow us to both expand them or condense them. And these are all right here in this box. So you can only do these when you're doing these, the base of your logs have to stay the same the whole time. So when they look like this, you can work interchangeably from the direction I write to the direction that's already in there. But let's go through and talk about what some of these properties are. So the product rule. So if you've got inside of your log two things being multiplied by each other, we can rewrite this as a log statement separated with addition. So I can separate that RS into log base B of R plus log base B of S. Okay, so anytime it's written as a product within logs, you can separate them as addition. Now, like I said, make sure your base doesn't change. So hopefully you see along the way that log base B stays the same the entire time. Your quotient rule. So if two things are being divided within your log rather than separate them with addition, we are actually going to separate them with subtraction. So it should look pretty much the same as the one right above it, except it's going to be subtracted instead of added. Okay, so those are the two big rules that we have there. The other one, we've kind of already looked at this. So remember what we talked about when we were simplifying logs and the base and the number inside the log matched. My answer was really my exponent. And the reason being is this power rule right here. So if you've got something within a log that has an exponent, you can actually just drag that exponent right out in front. Kind of like we did when we were taking the log on both sides of equations to solve things algebraically. So if you've got something written like this power rule, you can really rewrite it as your exponent, in this case C, times the log that you are already looking at. So those are our three main properties that we're going to be using today to both expand or condense logs, depending on which one they are asking us. So make sure you're pretty familiar with those. Now, for the sake of the fact that I'm not there and you're doing this through a video, we're going to skip number one. I'm not going to make you prove the product rule. It's okay. You don't necessarily need to know that. It's just a good thing to know. So let's go ahead and skip to number two. So it says, assuming x and y are positive, use property of logs to write log of 8xy to the fourth as a sum of logarithms or multiples of logarithms. So that's really just asking you to kind of expand it out. So if we started with that original log, so log of 8x y to the fourth, please forgive my handwriting. I'm going to post a nicer version of these notes in Classroom as well, so you can copy them down a little bit nicer. So the way we can do this, each of these things are being multiplied. We have 8 times x times y to the fourth. So using those rules from up above, I can rewrite this with addition between each of my logs. So this could be log of 8 plus log of x plus log of y to the fourth. Okay. Now, hopefully we can all see these are base 10. There is no log base written, so that's okay as long as you keep that consistent the whole time. Now, you don't necessarily have to, but just to give you another example, I'm going to actually rewrite 8 as 2 to the third, just to give you another example of using that power rule. So I'm going to rewrite this as log of 2 to the third plus log of x plus, log of y to the fourth. And now we've separated those all using that product rule. Now I'm going to use that power rule. So in both cases where I have exponents, I'm just going to move them out in front of that log. So in that first one, because I rewrote it as 2 to the third, I'm going to rewrite it now as 3 times the log of 2. That middle one, that log of x, can't change. So just plus log of x. And with that last one, again, I have an exponent, so I'm going to put it out in front, and it becomes 4 log of y. And that is what it's asking for, and it's asking you to rewrite something using those properties, okay? So that's as simplified as it would get. That would be your final answer. I know it looks messier, but that's just using the product of logs, okay? Now with question number 3, we're going to do something a little bit similar. This time, though, whoops. Sorry about that. Oh, okay, it's going well. All right. This time what we're going to do is now we've got one that's division. So we are going to separate them a little bit differently. We also have a square root in there. So lots of fun things that we've looked at before. So we're trying to rewrite the natural log. I apologize for my handwriting on the touch screen. Okay, so this time we have division instead of multiplication. So again, we're going to rewrite these, separating our numerator and our denominator into separate logs using subtraction instead. So the natural log of my numerator, so that x squared, or the square root of x squared plus 5, and then we're going to write minus the natural log of x. Okay. So that's that first step, is using that quotient rule to separate those. The next thing I'm going to do is we do technically have an exponent with that first one. We have that square root, which hopefully we remember from before break. Square roots are really an exponent of 1/2. So I'm going to rewrite this as the natural log of x squared plus 5 to the 1/2. And keep that minus the natural log of x. So our very, very last step to simplifying this is to move that 1/2 out in front. So this becomes 1/2 the natural log of x squared plus 5 minus the natural log of x. And that is as simplified as that can go. I know I've had questions in the past. There is that x squared, but because that exponent is not on that entire numerator, I can't put it out in front of my log. That's as simplified as this is going to go. You can't simplify that any further because you can't simplify addition inside of logs. So that is the simplified answer with that. So when you're asked to rewrite this as sums or differences or multiples of logarithms, this is what it's asking you to do. Now let's look at some where it's actually asking you to move in the opposite direction. So giving you an expanded one and rewriting it into a single logarithm, which is like question number 4. And then we'll be done listening to me for the day. So assuming x and y are positive, rewrite natural log of x to the 5th minus 2 natural log of xy as a single logarithm. Okay, so like I said, now it's asking you to rewrite these as a single logarithm rather than pulling them apart. So your first step here is kind of to move in the opposite order of the ones we just did up above. So our last step with all the ones that we just did on the first page of notes was to move the exponent out in front. So now what we're going to look at is to see if there's anything where we do have a number out in front that can be rewritten as an exponent. And in this case, we've got that 2. So I'm going to rewrite that now, moving the 2 back up into the exponent position. So this can be rewritten now as the natural log of x to the 5th minus the natural log of xy squared. Okay, so that 2 now just moves up into my exponent spot. To make our lives a little bit easier when we simplify this later, I'm going to kind of square that both pieces of that. So I can rewrite this now as the natural log of x to the 5th minus the natural log, and xy squared is really x squared, y squared. Okay, so that's what we have right now. Now, again, you're going to look for your power rule or your quotient rule. In this case, we have subtraction, so we're working backwards in our quotient rule. So what I'm going to do is I'm going to rewrite this now in a single natural logarithm. So you're only writing it with one log, x to the 5th over x squared, y squared. Okay, so you're just taking those two separate logs that we had, combining them into one, and we're putting division between them. The reason I said do it as two separate, or not as two separate logs, is because this is not equivalent to, I'll write it off to the side here, this is not equivalent to the natural log of x to the fifth over the natural log of x squared y squared. Okay, so that's what I mean. You want to rewrite it with a single log out in front, not a log in both the top and in the bottom. Those are not equivalent statements. Just be careful there. When you're recombining things into a single log, you should only have one log written. Hence the name, single log. Our last step to simplifying this is I've got an x to the fifth in the top and an x squared in the bottom. I can simplify that. Two of those x's are going to cancel out. So this becomes the natural log of x to the third over y squared. All right, so that's how you'd work backwards. Again, start by moving any exponents up and then combining things. If it's addition, you're going to use your product rule. If it's subtraction, use your quotient rule. You can now do questions 1 through 12 and the property of logs homework. I'm going to be checking all this homework when I finally get back. I'm not sure when that is yet. I will keep you guys posted. Like I said, if you have any questions, please feel free to email me. If not, I can answer questions when I get back. I hope you all have a wonderful day, and I look forward to seeing you soon.